In this lecture, we'll talk about two examples. One is find the equation of the line passing through the point 0, 3. X is 0, y is 3, which is on y-axis. Okay. Alright. And then the line passing through 0.3 and making a 30-degree angle with the line y equals 3. You know, 1, 2, 3. Here is y equals 3. This horizontal one. 1, 2, 3. Okay. So y is a constant. X can be any value. That's a horizontal line. Okay. Now, we know a point, and we know actually the angle. We can find out the equation. We know here is 30 degrees. Then we know what? We know tangent 30 degrees is actually the slope. You know, tangent is, this angle is rise over run. That's opposite side over adjacent. Okay. But we know tangent 30 degrees is what? If you remember previously, we have this picture. Okay. You see 30 degrees 1 over radical 3. Okay. So here is 1 over radical 3. So we know the slope. If you were told the angle, then you should be able to find out the slope. We know the slope and we know the point. We can write down the equation. Okay, by slope, or you may say by point. This is a point slope. Form of a line, which will be what? Y minus y, this is 3, times the slope, equals the slope, 1 over radical 3, times x minus x. X here is 0. Actually, you are done. Okay? Yeah, actually you are done. If there is no further requirement, you are done. Y minus 3 equals 1 over radical 3 times x. But you know, if you want to write in this slope intercept form, you may do plus 3 on both sides. And you can do is those two are cancelled. So then what you have will be y on the left hand side alone. And then right hand side is 1 over radical 3 times x plus 3. Okay, you're done actually. But you know, you may also want to rationalize this denominator times radical 3 on both numerator and denominator. So this function is actually equivalent to what? Y equals 1 times radical 3 is radical 3. 1 times radical 3. Radical 3 times radical 3 is 3. X. And then plus 3. Okay. Okay, that's the first example. The second example is the one right here. Without using the calculators, complete the table with exact trigonometric functions. So you are given this table, you want to find out what? Those three values. Okay. Actually, you don't have to be given those three values. You should be able to do what? Given this angle, find out all. Again, when you see the special angles, you want to draw a picture to help you. Yeah, with a picture, you can find out all the things you needed. That's the way, I learn at least. Again, here is 90 degrees. If this angle is 60 degrees, then the complement has to be what? 30 degrees. Remember, for 30 degrees, the opposite side of 30 degrees is always half of the hypotenuse. Okay? Yeah. I have explained this in the previous lectures. You may want to take a look. Okay, if here is 1, the hypotenuse will be 2, and here will be radical 3. Because radical 3 squared is 3, plus 1 squared is together 4, and choose the square root is 2. Now, you have these things in your mind, then 1, 2, radical 3 already here. Look at cosine 60, not 30. 60. Yeah, this angle. Let me highlight it. This one we are talking about. Okay. Now, then sine is what? Sine 60 degrees is opposite side over hypotenuse. So, it's actually you can complete radical 3 over 2. Cotangent 60 degrees. Cotangent is adjacent or opposite. Okay, that's 1 over radical 3. Again, you may rationalize that. Okay, as you did right here, you see radical 3, both numerator and denominator multiplied by that. You then will have is radical 3 upstairs, because 1 times radical 3 is radical 3. Downstairs is radical 3 times radical 3. Okay, so you have a radical 3 over 3. Okay, that's for cotangent. For tangent, that's opposite side over 1. That's why you got that. Now, for secant theta. Secant, that's the reciprocal of cosine. So here is 1/2, and here is 2. Okay, on the picture, cosine is 1 over 2. You see right here, 1 over 2, 1/2. And secant is the reciprocal of cosine. Then you flip this one, 2 over 1, which is 2. Okay, so please review this lecture. I'll see you next time.